So welcome back. Now we are going to start our speaker sessions. In our first session, our session subtopic is role of street furniture in 5G. Street furniture that can accommodate micro-level telecom infrastructure like small cell units in boxes and perhaps are visually appealing and approachable to public. In order to make street furniture suitable for small cell deployment, it should be able to take care of power, antenna, backhaul, and other cabling arrangements. Also, good design and engineering is very crucial for successful small cell deployment on street furniture. We are honored to have with us Dr. Amit Kumar from Indian Institute of Technology, Kharagpur, in this session. Dr. Dotto received his PhD degree in electrical communication engineering from the Indian Institute of Science, Bangalore. He received his Bachelor of Engineering degree from Shibpur, West Bengal. He worked in communication and VLSI industries like Texas Instruments, Broadcom Limited, Cypress Semiconductor, NXP Limited for almost 14 years. He has been with IIT Kharagpur since 2018, where he is currently as assistant professor in the GS Shamnal School of Telecommunications. His research focus on physical layer of wireless communications, wireless relay, community radio, and 5G and beyond. He has several journals, conference in IEEE. He holds several granted US patents to his credit. So over the session to Dr. Amit Kumar Datta, please.
Hello, can you hear me?
Yes, please continue.
So can I present now?
Yes.
Okay, thank you. Is my screen visible to everybody?
Yeah, it's coming.
Okay, thank you. So thank you, thank you everybody for giving me the opportunity to present this aspect of role of street furniture in the 5G context. Now, in this particular talk, I'll be going over various 5G angles where street furnitures can be used. Now, when you say street furniture, need not be just the electric poles or the buildings. I'll show you there are interesting aspects as well, where you may think over deployment of the 5G on those issues. So these are the these are the things that I will try to cover, 5G, features of 5G, and there are different use cases and the possibility for the 5G deployments. So let's say, I mean, just a brief introduction of what 5G. I think all distinguished speakers have talked a little bit about that, but just as a continuation, I'll show you one of the 5G deployment scenarios where you can see the small circles which can be thought of as a cell. Either it could be a large cell or a small cell. And all these cells will be connected either via wireless relay or via fiber optics core networks. An individual base station, which we call it GNB or ENB, they can deliver the data to their individual UE, or in our simple sense, it could be just the mobile stations or a mobile phones, could be laptop or could be an IoT devices. So this is a typical, the 5G networks which can be thought of here. Now you can see in this case, there will be a lot of small cells as well. For example, ACENB. So this is where the 5G's approach, like a divide and conquer, where you cannot provide it, you can just make it a small cells and reach out to our dense areas. Okay, so this is the standard for the 5th generation cellular networks, and it really enables a very wide range of communication protocol to coexist. So when you say 5G, not just the 5G protocol, it allows Wi-Fi, Bluetooth, everybody can coexist with the same thing, and that's basically could be an opportunity. So you really don't have to go through the 5G RF protocol. You can also, at some point of time, you can just convert it to Wi-Fi or other protocols to deliver the things here. And of course, the data rate could be huge. At the same time, data rate can be extremely low as like a 1 KB or even a 500 bytes. that kind of data rate is also possible, and it technically allows it, for example, in IoT kind of devices. So when you have this huge spectrum or huge things, this is a very simplistic view of the 5G systems, where you have a mobile, then you have a base stations. Now, when you say base station today in 5G context, they are not really exactly the huge circuitry that comes into picture. Mostly it will be a lot of RF circuits will be there, which is called RRH, and the computation will be shifted to other internal stuffs there, which will be connected using the fiber nets. So the base stations will be kind of where the RF is exactly sitting here, which is kind of a lean kind of things compared to the 4G. And this could be one of the opportunity in the 5G context, because if you look at the 4G, where the base station will have an RF and huge computational aspect there, but in 5G, base station can be lean, meaning just have the RF, but computation can be shifted to somewhere else centralized. So this could be an opportunity for us. So now there are, I mean, this is just a simplistic view. We have a mobile station connected to one of the RRH, and then they are connected with the fiber optics networks, and finally it could be delivered to another lean kind of RRH or a base station, and then again it will be connected to another mobile station. So this is a simple kind of views here. Now, where given this view, given the aspect that base station can be a lean in our case, so what we can do to utilize the existing infrastructures to make it possible for the deployments. And I will go through several scenarios where we can thought of deployments. Okay, so let's talk about few of the features. It has a high data rate of 10 Gbps. I mean, all things are kind of known to everybody, but I'm just repeating. 100x speed improvement over the 4G. Latency, of course, 1 millisecond latency, and then 100x improvement of connected device, which means that if you have a base station with a macro, it can connect up to 1 lakh devices, including all the IoT devices. And obviously, it's a low-powered things for the 5G. And one of the features that 5G has, that it operates on the sub 6 gigahertz as well as on the millimeter wave, which is above 30 gigahertz, 30, 42, and beyond. So that's what the things are coming up. So this is the data rate. You can look at the 5G now comes about 10 Gbps, but that's not the average data rate. It's kind of a peak data rate. The average depends on the number of devices connected. So where we should focus now from a street furniture utilization angle. So our key focus area will be the utilizations of the existing infrastructure, which is a street furniture infrastructure. So it could be street lights, it could be buses, lorries, public transport, everything. I'll show you very interesting case studies there. And it should be such that the infrastructure should support that lean base station I'm talking of, where there will not be too many huge circuitry as compared to the 4G. Just lean, only the antennas and probably few of the RF circuits. Okay, and one of the requirement that obviously it's a consistent power and long-standing pole would be the fundamental part of this aspect. Another issue probably, which I don't know how we can address, and one of the distinguished speakers says that the optical cabling, penetration of the optical cabling is low. So that could be one of the issues when we talk about the street furniture things. And I will touch upon to overcome such issues, what could be the solution. In fact, 5G gives a very interesting solutions even for that as well. And public transport system like train, bus, can they act like a base station? So instead of just the pole, electric pole, where you have, of course, you have electric poles, but not everywhere you have electric poles, right? Like a roads, like a highways. Not everywhere you have electric poles there, right? So can the train or buses, especially the buses, can act as a moving base stations? So we'll see that. Okay, so I'll talk about various scenarios, and that constitutes the complete talk here. So this is the conventional 5G base station, which we all know have a huge tower, antennas, and those things, which we are proposing to this kind of scenarios, where you have a lean base stations, single base stations, and along with the base stations, you can have a small antenna there and a junction box. Now that box may contain various electronic circuits, power supply circuits, and all. Now, as I said, 5G only it's an RRH, that means remote radio head. So you really don't require a huge computational circuits compared to the 4G, where you have a huge base stations, or you have computers and all. That may not be required in this case, because it is only the just the RF part to electrical circuit conversion, which can be small circuits that can be put there. So that makes the things possible. And I think some discussions were also going on what could be the weight and all these things. To be very frank, this should not be a huge weight things if you think of the way the 5G base stations should be considered, because the actual computation is actually centralized. So the just the antenna and its conversion of electrical signal may not be a huge weighted kind of circuits, maybe a small circuit which can do the things. So a small even a small electric pole can do the job of a 5G base stations. Okay, so this can be one of the deployment scenarios where you have a dense locality and you have a road, and on both the sides you can have a street light which can be acting as a small cells here. Now, given that, there is one thing that we need to see, or maybe we need to understand: what about the connectivity of these things, these poles, to the computational unit or the BBU unit? Because this is only the RF receivers. Okay, that means it can only take the RF signal and just sends the signal, but actual computation may not happen here, so it has to be somewhere else. So all these things have to be finally connected through fiber optic cables or by a wireless link to the BBU unit, where the actual computations happens. So now, as we know, the penetration of the fiber optic cables is not as good as what we think here. So this could be one of the focus area to make the things possible here. So it is not just the connectivities from the wireless, but from these poles, how do you take it to the BBU? That could be one of the focus area. Now, given this, so I have put a dotted line here, so which means that this could be a simple fiber optics, or this could also be a wireless relay. So which means that you may not really need fiber optics for that. You can just connect all these small this small RRH unit which is on the street light. They can be wirelessly connected to the actual control units or the actual computational units. So that is also possible, very much possible in the 5G deployment. So the ORI of fiber optics may or may not arise depending on how dense these things can be populated. Okay, some of the pros and cons, kind of known, but I'm just reiterating. It has to be a tall pole, obviously, because taller, it can make the area coverage larger. And no need of any private lands rental. Obviously, this is an advantage, but of course you have to pay a rental to the municipality or any other governing body who actually erect those poles. So that's a different aspect, but it will be much lesser than a rental from the private thing. And consistent power supply. This could be one of the issues for making it work. Now, as power supply is an issue, could be a solar cell kind of backup can be one of the options there, or some sort of a power backup has to be there. So these are the things. And then the circuit box of that base station, which is not huge because it's an RRH unit of 5G, but still it's there. I mean, it can be like a 1 feet by 1 feet small box, but where will you keep it? That can be it can be stolen or broken. So the security of that box itself, so can it be underground? So you have a pole and can it be kept underground, which may be thought of. Okay, so the next ones are, again, I just continue with them. So circuit of that base stations are costly, but if it is RRH, probably that may not be so costly. And so that's what I say, it can be kept in the underground. And such kind of configuration, when you say small cell, will be very well suited for the millimeter wave communications. Now, if you say 6 gigahertz, the antenna size will be bigger. Probably that has its own way of logistics. But when it is a millimeter wave, the cost will be much lesser in terms of the deployments. So that can be one of the thoughts where small cells can, in fact, adopt to that. So small cell can be taking the millimeter wave communication rather than a sub 6 gigahertz communication from the deployment point of view. Okay, and if it is a millimeter wave, you can have, in fact, a very large number of antennas with a small area. I'll show you that, how small that area can be. And in fact, it can fit in our meter box, or it can even be fit in the light box also. if it is a millimeter wave. And this is one of those, as I said, the fiber optic connection. But not all the time you need a fiber optics. You can actually, if fiber optics is not there, you can also have a wireless link, which can be a relay link to the actual computation. So fiber optic can be an issue or may not be an issue, depending on how exactly your deployment strategy would be. Okay, so this could be the antenna size. It can be a few centimeter cross few centimeter, and it can have some 16 to 64 kind of antennas if you have a millimeter wave. Now, can you believe it? Just you can put it in your palm, that whole millimeter wave antenna is, and that can serve simultaneously probably 30 to 40 houses at the same time using this millimeter wave beams. So now you can see, so if you have this kind of antenna, so you can fit everywhere, right? You can even keep it in your pocket just for this antenna boxes, right? So that, that drives us, or that probably forces us to think the street poles or street lights, can they act as a the keeper of these antennas, because that will be anyway kept at the little upper side, and these sizes will also not be very high. It will be like a small few centimeter cross few centimeter, and which can serve 30-40 houses at the same time using a millimeter wave beams. So can I have it there? Yes. So you have millimeter wave small antennas, and you can well keep it within the small boxes. Okay, because the sizes will be few centimeter cross few centimeter. So this is one of the advantage if you have a millimeter wave small cells compared to large, compared to 6 gigahertz small cells. Okay, so this could be one of the advantages here. And of course, you can have these street light boxes can act as a safe antenna board. Wiring fitting of such board, it is possible very much, but that needs an extra electrical connections and so on and so forth. Now I go to the second scenarios where, so this is the domestic scenarios where you have a dense population, you have a street lights and so on and so forth. But what about the highways? Let's say now today in 5G, we are talking of 5G based internet providing on the highway itself, because highway may or may not have internet connectivity. If you think a highway going all through the rural regions, and then it can go through the forest region, so providing internet on those regions may not be a very, it should be a very challenging job. So how can you do that on the highways? So now let's see what can be done here. Now 5G supports such kind of concept using a V2V or V2X communication or communication while driving. Now 5G and now highways may not have base station supports from outside locality. This could be one of the things. So now who can act as a base stations? Okay. Now again, the same concepts. If you have a highway where a lot of street lights are there, all the street lights can act as a small base station, just like your locality. Now this can be an interesting point where on the highway you can provide internet on all these street lights. Again, the logistics issues are same as what we talked about when you have a dense localities there. The same street light poles, whatever issues there we have discussed, that you can have the same issues there. Now again, this could be the pros and cons side from the highway side, that street light poles can be utilized against for the small base station. It can even be millimeter wave also, because street lights on the highways will be, I mean, it may be 100-meter arrays, right? And millimeter wave, you can well have it there. So you need not to have a 6 gigahertz base station. Rather, you can have a 30 or 40 gigahertz kind of small cell base stations there. Okay, and another things that I will talk about on the highway things is that, can the public bus or the private big vehicles act as a wireless relay networks? I tell you why that comes into picture here. So let's something called a blind zone. Okay, because in the highway, not every place in the highway you have a street lights, right? Only vicinity of some areas you have a street light, but not everywhere. So there will be blind zones. That means there is no street lights there, in fact. So how do you provide? Because now if you say I want to provide a 5G internet on the vehicles itself on the highway, and I do not have poles or electric poles on the highway everywhere, then how should I provide it when there is no electric poles? So can I have this scheme? And this is very much supported in the 5G context. It was not well supported in the 4G, but now in the 5G it is well supported. So there is something called a 5G relay. Okay, now relay, we know what is relay. It takes the data and just sends the data to another forward movement thing. So can these buses or lorries can act as a relay? So that means you have a bus which is moving on the highways, what it will do is that you keep a 5G relay node there. Okay, so you have hundreds of buses which can be 50 meter, 10 meter, 100 meters average, like the way the vehicles move on the highways there. But all these all these vehicles will now be fitted with the 5G nodes there. But those nodes are not just a conventional transceiver nodes. They are the relay nodes. And this relay is extremely supported in the release 17 and going to be supported onward for release 18 and so on and so forth. So this 5G relay can be thought of. And all these moving vehicles, now you can see, say, let's say I have this car, okay, and I'm in the blind zone. Okay, I do not have any internet. But however, there will be a lot of vehicles where this bus can have a relay node here, and it transmits the data to the next vehicle, which could be a lorry or some other van kind of thing. And if it is nearer to me, I can well get the service there, right? So it's kind of a dynamic base stations, like it's a moving base stations, and this can be well supported, and you really don't require poles there. And this is supported in the 5G as well. And the good part is that all these vehicles come with a height. That's what I propose that. So because the bus and lorry have a height, at the same time, they have electrical circuits. So the power can be supplied to them, and they can serve at least 100 to 200 meters, or it can even increase depending on the power. 300, 400 meters also it can, it can support to provide the 5G services there. Okay, so now power supply obviously is not an issue. Now this is another part where 5G can play an important role. Highway safety with the radar. Now this is a concept that 5G well adopts it. The concept is called a rudder technology. Now the technology is also known as a rudder communication technology, which means that you have a communication system. At the same time, you have a coexisting with the rudder. Now, in 5G, the rudder spectrum is kept separately just to support that. So what it means that if some places you need to have a safety related thing, for example, on a highway, two vehicles are approaching. Okay, it could be a rail also, it could be vehicles also approaching. Now, how do you know that I do not face any collision? Or maybe that particular vehicle is not moving in a very good way? Probably drunk driving or whatever reasons, or it may be over speeding. So as a driver of another car, how do I know that it is not colliding with me? So these are the things are well thought of, but in 5G it is now being supported. It can be supported using a rudder. Now when you say rudder, so it opens up another box of Pandora's. So you have a 5G things, you have a rudder things. Okay, now rudder is not the conventional rudder or like warfare radar. It's not that. It's a very low cost radar where the power is not going to be 30 to 40 dBm power. It's a very low cost radar which can be fitted within your mobile phone itself, or it can be fitted within your car itself. And in fact, all these new cars, new mobile may come up with these small rudders. Now, if you have these rudders, in fact, we have a very interesting scenarios where it can be used. The street lights or the street furniture can be used for the rudder things. So suppose I have this kind of scenarios where you have a blind spot. In fact, this is one of the things that we are trying it at the IIT KGP as well. So you have a blind spot. So this car is moving from the highway side, and nobody interacts with each because there is a blind spot, because it is a kind of car. Now this car is not seeing these vehicles, and it can be in the blind zone, probably in the hills region. Now the problem is that as nobody sees the vehicle, so there is a risk of collision. And today, if you look at the way the modern highways are designed, that when you have this blind spot, there will be a board. It could be a billboard, or it could be a street lights as well. Most of the time, you can see that today's modern highways are in fact designed that way. So can I utilize this billboard to provide me signal that, hey, there is a vehicle here, and give that information to the blue vehicles? Now, this is possible if you have a 5G rudder technology. So what it does is that simple. This billboard will have rudders, and he will send signal to both ways. That's his job. So whenever he sees that this particular vehicle is coming, he will send a signal to the blue one and says that, hey, that vehicle is coming with so and so speed. Now this particular blue vehicle may take an action. Okay, so he can say, okay, some vehicle is coming, so I need to take an action. Now such things is not possible using a Google map. In the Google map, you can see some vehicle is coming, but there is a delay, right? It can be few seconds, 10, 20, even a minute delays. Okay. So that the fast, the fast snapshot of such kind of blind things are possible using this radar. And you can well utilize this billboard, or you can have a street lights there where all the radar kind of circuitries you can put there. And this is part of the 5G. In fact, there is another interesting part here, that though it is part of the 5G, you really don't need a 5G signal there, because this can be a local networks. It can be a 5G protocol, but this can be a local network. And that gives us a huge advantage, because that does not require that this should be connected with a infrastructure. It can be just a simple simple radar system, which is a 5G protocol radar system, and it just makes a local communication to the system, provided that both the vehicles have a 5G mobile phones. Okay, and you can utilize the billboards, or you can utilize street lights to install the radar system. And again, the size is very small. As I said, it is not a conventional warfare radar. It's a 5G radar. So what is the size? Size will be small, centimeters cross some centimeters cross some centimeters, because the spectrum that people are talking of in the 5G radar is 80 to 90 gigahertz, and the power is also 30 to 40 milliwatt, dBm. So if that is the case, then size of those antennas can well fit within few centimeters, right? So I don't need a huge system to, I just need a height kind of a pole and just a small continuous power supply, which can really act as a blind spot, blind spot safety kind of things on the highways, and everything can fit within that. Okay, so next scenarios that I'm talking of is the public transport on the smaller road. So as you said, public transport on the smaller road can well act as a 5G backhaul. Why? Because on the small roads, you may not have a street lights all the time. So who can act that? So I just directly go there. Let me go to the diagram itself here. If you have at least one street light here and there, need not be just 100 meters away. So let's say I have one street light somewhere 1 kilometer away, good enough for me. I have multiple such vehicles, which can be again fitted with 5G relay system, which is not a conventional 5G transceiver. It's a 5G relay. Small boxes nowadays come. You have the 5G transceiver with a relay feature. That's all. So it's small boxes. Probably a small box can be fitted to that. And then it can be transmitted to another 5G system, which can be a relay as well as the transceiver system on a bus. So let's say a public transport bus. And that bus will internally provide a Wi-Fi to all its passengers. Now, this kind of system always exists, but the only difference here is that that bus is now having a conventional 4G kind of system, and then it converts to Wi-Fi. Now, what we are saying is that why not take the combinations of 5G relay and the 5G system fitted on other vehicles as well as on the street light. So that can give you even a better, service or rather reach of the 5G on that on the 5G network systems. The next scenarios which I thought of, and it can well utilize the 5G deployment things. What about the railway signaling system? Now, railway signaling system, you have the railway signals where you can again fit your 5G transceiver there. But the issue is not that. Issue is that, can I utilize them to provide internet or rather 5G to other areas, not just on the railway track? Because you have a railway track today, and you have several such signals, probably 50, 100 meters away. I don't know that exact distance, but you can provide internet within the train. That's fine. The same way that we have done for the dense areas. What about the side-by areas? Because when the railway track goes, it goes through a lot of agricultural lands and forests, right? So from there, can I provide internet up to 5 to 6 kilometers inside agricultural land? But because today the agricultural lands comes up with a lot of 5G technologies and sensor related things. So when the agriculture becomes tech savvy, when the forest areas are also becoming tech savvy because you have to track several other technological aspects, can I provide internet in those areas from railway track, both sides 5 to 6 kilometers? So you can say at least 12 kilometers stretch of my infrastructure, 12 kilometer stretch of 5G service providing can be done using the existing railway tracks. Okay, so this is another interesting proposal that can be thought of going forward. Now, again, this has no issue from the power side. This has no issue from the height wise, because you have a long, signaling poles which can provide the links very well. But this would be required, provided that at least the side-by villages on the tracks can well be connected using the 5G networks. Okay, so now this is what I have said. Last but not least, this is my last slide for the approaches of the street furniture. Now, as I said, today the agriculture is becoming tech savvy. Now, when I say tech savvy, what does it mean? It means that today we are having agriculture things where technologies are being used from the 5G point of view. For example, sensors. Okay, you have a lot of modern farmings where people in fact install a lot of sensors. For example, it could be soil, it could be a moisture sensor, it could be heat sensor, many other sensors, hundreds of thousands of sensors nowadays are being deployed on the agricultural field. Now, having all these nodes connected with the 5G is desirable, but it is a very difficult task, right? Because you cannot connect all such small node with the 5G. That will be very costly for a small farmer kind of people. So you have a sensor which are low cost, but can I have this sensor connected with a 5G in a different way? What? So let's say I have a tractor, okay, and that tractor it will be digging the fields, or it will be going through the fields whenever it is required, right? So the tractor will just go through the field, and whenever it moves, that has a sensor receiver, okay, and it has a 5G nodes. So whenever it moves away, it's like all the sensor will be immediately connected whenever it comes closer to it, and it just gets connected. Now it could be a tractor, or it could be other tall agricultural machines, whatever. I mean, there are many nowadays coming up. So now they all just, it's kind of a data collection. So the tractor just moves, it collects all the data from the sensors. Now the tractor goes to the the main places where there is a 5G networks, and they just offload the data there. So you have acres after acres, huge vast land, thousands acres of land where you have sensors, and you do not want to connect all these sensors directly to the 5G backhaul because that may be costly. You just have a 5G nodes or sensor receiver on this kind of agricultural moving machines. It just collects the data, and whenever it goes to the system or main nearby to any base station, you just upload the data, and anybody can access those data after probably 1 hour or something. So this gives another infrastructure where kind of an offline and online modes, where you have an offline data collection and then you go to the online, and that can be acting as a moving base stations. And of course, there will be legislatures required, there will be other rules and regulations required for all this. But this could be one of the aspect that can be thought of from the street furniture use aspect as well. Okay, so these are the things. So in conclusion, we have talked about various use cases regarding the role of the street furniture. So it is not just the poles, it can be moving vehicles as well, which can be acting as a relay, as we said. And this is one of the stress points should be there, because you have a lot of blind spots. Poles cannot act as a base stations all the time, because you have a blind spots, and then moving system can be a good alternatives. And we have also shown that few basic steps need to be done to increase the reach, like relay installations and so on and so forth. Of course, what remains is the safety and consistent power supply. That is an issue, and that needs to be addressed in near futures. Thank you.
Shall I close the presentation?
Yes.
So thank you, Dr. Datto, for delivering an exciting session. The concept of small cells on moving vehicle is really fascinating. Basically, it would be a BTS on wheel, and perhaps very much helpful for rural and semi-urban beds. Until now, we are thinking that involvement of state government, IT, or urban development department or rural development departments are very important. But now we have to involve transport department also. So thanks for being with us. We look forward to your kind patronage in future. Thanks a lot once again. And for question and answer sessions, we have clubbed together all the sessions, and after concluding all the sessions, we'll arrange for the question and answer sessions for save our time basically. And it's a request to the participants, please be with us in the question and answer sessions. Hopefully, Dr. will be available to give to give the answer your queries. So now we are coming to our second session, and as India is in process of launching 5G this year, small cells can play the vital role in network expansion and upgradation. With the perquisites of appropriate signal strength, consistent network coverage, along with other 5G inherent features, 5G may need to be deployed in relatively high-speed bands, but this may poses the disadvantage of covering short distances and not able to travel through building of obstacles. Therefore, in a densely populated cities of India, the role of street furniture comes into picture to accommodate small cells. And in our session topic is use of street furniture solutions in Indian market. In this session, we have an eminent speaker from Nokia India, the pioneer in mobile switchgear company. Let us welcome Sri Sanjeev Kohli, Head Mobile Network Pre-Sales, Nokia India. Sri Kohli has a global experience in the telecom industry spanning 30 years across multiple organizations, Nokia, Alcatel-Lucent, and CDOT, and multiple geographies, India, Middle East, and Europe. He started his career as a telecom software engineer in CDOT and moved on to mobile networks deployment O&M at Alcatel-Lucent, UAE, where he was the CTO for Etisalat Global Account. He has been with Nokia India since July 2011 and is currently heading the mobile network services pre-sales in India market. So over the session to Sri Sanjeev Kabuli.
Thank you so much, Mr. Datta, and thank you so much, Dr. Samant, for giving me this opportunity to be to join this webinar, and all the esteemed and distinguished dignitaries from government departments and from various other industry stakeholders. It's indeed an honor and a privilege to be part of this session today. So I'll be sharing my in fact, we have been working together with Mr. Rajiv Tyagi and team over the last more than 2 months, who are formulating the guidelines to be applied across India for the usage of street furniture. So I would say we have been sharing with them and working together with them. And indeed, as well said by Mr. Sinha, also this requires collaboration and across all the industry stakeholders. And it's indeed imperative for all of us to harness the benefits of 5G technology to its fullest potential. And of course, for this, everybody needs to collaborate together. So I will start sharing my screen.
Yes, it's coming.
I hope my screen is visible.
Yes, it's visible. Please continue, sir.
Yeah, sure. So I'll be talking about the small cell solutions. So basically, sharing, I would like to share with you various, I would say, learnings and best practices also, which we have been deploying in various networks worldwide. And
Sir, sorry, sir. Actually, there is a slight. Sir, sorry, sir. Actually, there is a slight miscommunication, sir.
yes,
Hello?
please. Yes.
Sir. Actually, your schedule was third session, sir. I am sorry, extremely sorry. There was a miscommunication, sir. Extremely sorry, sir.
Okay, no problem. No problem. So I will stop sharing. Yeah. Yeah.
Sir, I am extremely sorry, sir. I am extremely sorry, sir.
No
Please
worries. No
forgive me,
worries.
sir.
No.
No, sir. It is a miscommunication. I am extremely sorry, sir. I am really simple act from me, sir.
Sir,
Sir, if you can
perhaps,
continue.
sir is saying,
Sir, I
Mr.
am
Kohli, you please
extremely sorry,
continue.
sir.
Perhaps he is talking to someone else.
Okay. Okay. I thought
No,
the
no, no,
message
no,
was
no.
for me.
Sorry for the interruption. You please continue.
No worries. No worries. Yeah, I'll do so. Yeah. I hope my screen is visible. Hello, I hope my screen is visible.
Yes, sir. Yes, sir. Please continue.
Yeah. All right. Okay. So I'll be taking you through quickly our Nokia small cells portfolio, as well as the various deployments that we have been doing worldwide across various networks, and of course how we can, I would say, leverage the learnings from these global deployments, and of course develop and so I would say co-creation is the right word over here, and as suggested by, I believe, Mr. Sinha also. So we would need to create and to, I would say, fine tune the appropriate solutions, keeping in view the Indian environment as well as the aesthetics and the various other aspects. Right. So, starting with the Nokia small cells portfolio, so we have got a wide range of portfolio covering from in-building solutions going on to outdoor solutions. So, and of course, across all the technologies, 3G, 4G, and 5G. So, from in-building residential, I would say it's like a femto node, or what a smart node we call. Then for the large in-building solutions like corporate buildings or shopping malls and all, we have got AirScale indoor solution, which supports both 4G and 5G. And then we have got FlexiZone AIO, which can be used for both indoor as well as outdoor applications. And then micro RRH and medium power millimeter wave. So medium power millimeter wave is primarily targeted for 5G applications, whereas the micro RRH can support both 4G as well as 5G. So all of these, the left three which you see on this screen, so these are applicable for outdoor applications. So, in terms of the model site designs for outdoor model site solutions, so in fact, what are the major key considerations? So, first is the flexibility for the site selection, optimal utilization of the existing street furniture. Then, in terms of quality, so it should be something that is easily replicable, so that the consistent quality can be maintained. Delivery, of course, easily repeatable solution and cluster deployment, which will lead to faster rollouts, which would be, of course, a key success factor in 5G implementation. And of course, in terms of cost, it needs to be cost effective and standard site solutions as far as possible, and designed to be to ensure the lowest TCO. So from the CSP perspective, I would say, I mean, based upon our discussions with the various CSPs in this context, so for them, the top priority remains to minimize the TCO, so that the ROI can be maximized, and it makes good business sense for them to implement the small cells as fast and as, I would say, extensively as possible. So in fact, I'll be coming to details of each of these types of solutions. So we have got like the telephone booths, or the bus stations, or a kiosk on the streets. So we'll be going through each of these scenarios in a bit more details in the coming slides. So there are various street furniture opportunities available, I would say, in terms of deployment of small cells. So there can be transit structures, which are the metro stations, for example, or the subways or the underpasses. We have got the information pillars or the billboards. Then there can be public gazebos and shelters, which can be used to deploy such equipments. Public park concessions, or some kiosks, either in public parks or in public areas. Station news vendors or shops on the station platforms. Concourse retail, so whereby, I mean, on the various pedestrian passage areas, we can have these deployed. Mall kiosks, and of course public toilets and public amenities. In terms of deployment solutions, so we can have, as we said, the lampposts or the bridge structures, the traffic light poles, bus stop or the advertising poles, and of course also the wall installations. So whereby we can directly deploy these small cell solutions, which have been very widely deployed, I would say, in most countries in Europe and all, on the wall mounts also. Yeah. So in terms of the urban densification challenges, so in fact, this schematic is showing the various options, so whereby these can be deployed. So we can have the street lights, the billboards, the transit shelters, vendor kiosks, concourse retail, and so on. So coming toward the first option, so that is the light and utility pole solutions. So these are, I would say, standardization of poles across the distribution networks. So this is the biggest advantage, I would say, because the types of poles in one particular circle or in a geography, they will be almost similar, and hence all the processes for installation and deployment of small cells, they can be harmonized, which will help to increase the speed as well as bring costs within the business case tolerances. And from the planning perspective, these can be considered low impact in terms of like the infrastructure is already available, and usually the AC power is also available, so they can be easily, I would say, used to deploy the small cell solutions. And of course, availability of utility fiber backhaul can be leveraged wherever appropriate to minimize the cost and the complexity. But yes, as some of the speakers, they also highlighted that yes, availability of optical fiber and fiber backhaul, that is one of the key uh, requirements, as well as can be one of the key constraints. And of course, there are other backhaul solutions also, like E-band microwave and all, but they would be applicable only, I would say, where the ROI, it makes sense to deploy such solutions. And also, of course, microwave will add additional load on the poles and all. So there might be selective usage of such scenarios. In terms of the model site solutions, so this is showing typically how the small cells have been deployed in various street lamppost situations. So typically on each lamppost, I mean, assuming that it's covering a road or a highway, so there will be two small cells deployed covering both the directions, and of course there will be the power and the optical fibers which need to be routed to reach the small cells. So these are showing the couple of examples of the actual deployed solutions. Common antenna options for outdoor. So in fact, we have got equipment which come with integrated antennas and baseband, and of course the on the left hand side which we had shown. So these are I would just like to come back to this millimeter wave. So millimeter wave is having integrated antenna, and because it is part of the radio equipment itself. And on the right hand side where you see, though, these are integrated baseband and antennas. And for the other equipments, we can have the option of additional antenna too, depending upon the planning considerations and requirements. Another very common option, especially in Europe and some of the Asian countries, it is the bus shelter solutions. So where typically you have got the large billboard also, either in an information board or an advertising board. So whereby you can see both the bus schedules as well as some advertisements and all. So this is showing a typical structure. So whereby on the top of the pole, bus shelter pole, we have installed the small cell, and the power equipment and the other routing equipment, they can be either on the behind the billboard or on the side wall of the bus shelter. So this is showing another example of transit shelter. So whereby, so you see these equipments which are shown on the they are actually on the back side of this information board, and the antennas are there. So integrated along with this pole with the clock, and the antenna is there. So to suit the aesthetics as well as, I would say, the practical requirements of having around minimum 3 meters height, 2.5 to 3 meters height, in order to have good coverage, as well as to take care of the aesthetics too. Another example of bus stops. So we have got quite a few of them. So this is particularly from London, UK. So we have got these kind of integrated. So whereby you can see the various bus routes which are serving that bus station, and then on the top you have got the external antenna and the Nokia, where you see this small yellow box. So Nokia small cell is housed within this small structure, so which is adjacent to the bus stop. Then another very common option is to use the billboards. So billboards also typically they have got space, you see on the bottom of the billboard, so there is space for housing the equipment, the electronics, as well as the power backup and all, which whatever is required. And of course the antennas, they can be hidden on the top, or it can be an integrated antenna within the equipment, as you mentioned. So both options are available. This is another typical design for a billboard. So whereby such kind of, I would say, detailed designing, of course, in terms of CAD drawings and all, needs to be done jointly with the CSP and the infra provider. So in order to come out with a standardized solution, which is easy for O&M as well as which is easy for installation. And of course, there can be wall-mounted or bridge-mounted large billboards also, or along the highways. So whereby such Nokia small cells or small cell solutions can be deployed. So wherever you see these yellow rectangles, so these are where the Nokia small cells can be deployed. So typically, I mean, we have got this kind of bracket structure, so whereby we can easily deploy whatever equipment is required. Of course, for covering large areas, so the RRH or the millimeter wave will be recommended due to their high power. Another example of billboard. And then we have got the street cabinet solutions. So we can have independent standalone street cabinet solutions also, so which can be either integrated with a billboard solution, or they can be even standalone solutions which can be deployed. So in some places, this option has been exercised. And then typically the wall mounted, as I was mentioning, either on the residential buildings or mainly on the commercial buildings, on the high streets and all, you can see several of such solutions deployed directly on the walls and integrated with the existing infrastructure. Yeah. And CCTV cameras. So these camera poles, these can be another option. Even in India, for Bharti, we have deployed on several CCTV cameras, the camera poles, these small cells, and they are working well in hotspots, because typically the CCTV cameras, they are installed in high traffic areas or traffic junctions, so where naturally there will be a lot of I would say pedestrian traffic or vehicular traffic, which can be catered to using the small cell solutions. So they can be used to cater to high demands in bandwidth as well as capacity. So just to share with you, I would say in terms of the proposal regarding the next steps. So we in Nokia, we would be very much interested to take this forward. In fact, what we would like to highlight is a few points. So first one is that one size fits all approach can't be adopted, since all the showcase solutions, they are customized as per the local CSP and market requirements. And the IPRs for the various designs, which I just showcased in the previous slides, they are owned by the respective either the respective CSPs or the design and marketing agencies. Like in Europe, we have got an agency called JCDESU, who are operating in several countries. So it's basically a marketing agency, and they are designing the billboards for the bus shelters as well as independent standalone billboards across the street furniture. So the IPRs for these detailed designs, they are owned by either these marketing agencies or of course their respective CSPs, and in some cases jointly also. So from Nokia perspective, we have got a dedicated central site solutions team in India market who are based in the same office as myself in Gurgaon in our corporate headquarters. Along with, we have got our ecosystem of partners. So what we would like to suggest and to propose is to jointly evaluate, develop and test in the form of field trial and POC, all the practical solutions for small cell deployments. So for example, there can be several considerations related to the wind load as well as the other considerations in terms of the height supported, especially if you want to deploy these solutions on electric poles. So in fact, we have shared all such information with the TRAI team also. I would say just a second. So and Nokia inputs have also been incorporated for in this Word document, which has been this is a template for the moment, the draft document which has been published just last month by the TEC DOT committee. And in as part of this document, we have shared all the inputs related to backhaul requirements and our typical system requirements in terms of what would be the typical, for example, this table has been shared by Nokia in terms of millimeter wave, micro RRH, flexi zone micro. So what is the radio output power? What is the weight? What are the physical dimensions of these modules, as well as the temperature range within which these can work? And of course, all of them, they are IP65 rating. And then in terms of the backhaul connectivity, what are the various options like optical fibers and microwave, etc. So all of them, they have been highlighted at of course at a brief level, and the details need to be worked out once we go for the field trials and the pilot trials. So what I would suggest is, if we can, like the same we had proposed when we were discussing with Kerala State Electricity Board also, as part of this joint working group along with the TRAI. So basically, we would love to assess the suitability of these poles to deploy these small cell solutions. And we have been working in several such projects. Like, for example, if I would just like to share with you the couple of examples. So this is the Nokia Smart Pole, which we had designed for BSNL, and as part of our smart city initiatives also. So around 35 of these smart poles have been deployed already in BSNL network across India. So so this was an integrated smart pole with facilities for LED lighting, remote surveillance, billboard, and you see the remote surveillance camera here, and also the equipment housing and the antenna to be camouflaged. So with all these facilities integrated. And then we have also worked for an outdoor cabinet, especially for VIL, depending upon their requirement. So what I want to say is, we need to work together for these customized solutions, which can be, number one, to test their applicability in the practical scenario, then to fine tune the solution, to assess its easy installation as well as operations and maintenance, and any other potential challenges with respect to the existing installations or the wind load factors, etc., which might need to be considered. And once the pilot and the POC has been done, then of course we can come up with a joint, I would say, plan to industrialize and to massify the implementation of these small cells. So we would be more than ready, and we are already engaging, and we would love to go towards the field trial and POC stage, where we can jointly assess the and to take this forward. Yeah. So that's all from my side.
Shall I close the presentation?
Yes, please. Yes. Thanks a lot. Thank you so much.
Sanjeev ji, aap rahiye, because there will be some questions.
Thank you, for sharing with us the Nokia way to implement small cell deployment for 5G. It would be of great help if Nokia set up such a POC arrangement in eastern part of India also, in collaboration with
sure we would love to do so. We would love to do so.
State governments.
Yeah.
We look forward to your kind support in coming days. So thank you, Sikahuliji, once again. Please
Most
stay with
welcome.
us.
Most welcome. My pleasure. Yeah.
Now we are coming to our third session. The session topic is on 5G challenges and enabling technologies, small cells. And in this session, we feel honored to have Professor Pritam Kumar from Indian Institute of Technology, Patna. See, Pritam Kumar is currently working as professor in the Department of Electrical Engineering, IIT Patna. He did his PhD from IIT Kharagpur in the areas of wireless cellular communications. He has around 20 years of teaching, research, and industry experience. Physical layer issues in wireless communications, 5G network, error control coding, and digital communication systems are his areas of research interest. He has published over 100 research papers in various referred IEEE journals, other peer-reviewed journals and conferences. He is a regular reviewer of premier journals and TPC member of various conferences. He was the organizing chair of first IEEE synopsis on 5G in Asia at IIT Patna in 2016. He has supervised 7 doctoral theses and more than 30 MTech projects. He has also successfully executed high-value sponsored projects from Government of India, as well as consultancy projects from industry. Apart from his teaching and research activities, he is also part of many administrative and government and governing committees at IIT Patna and other premier institutes and organizations. He is also serving as the editor of Springer Wireless Network Journal and International Journal Wireless Personal Communications. So now, over the session to Professor Pritam Kumar.
Thank you and good afternoon to everyone. And I think I'm audible.
Yes, sir.
Yes. So, thank you. I'm thankful to Dr. Swadesh Shamanta for inviting me, and definitely it is a privilege to deliver a talk on a platform hosted by TRI. Right. So let me share my slide.
Amit, sir. Sir, are you facing any trouble?
No. Is it visible?
No, it's not coming, sir. Now it's
Now
coming.
it is visible. Yes.
Now it's coming. Please continue, sir.
Sir, make it slideshow.
I made it slideshow, right? Is it visible?
No, it's,
Yes. A full slide. You please give it to full.
screen.
It is full screen now. Full screen.
Oh,
Okay, sir.
okay, sir, go ahead.
Is the second slide visible?
Sir, we are on the first slide, sir.
No. So then there is some issue.
Yeah,
right?
it's coming, sir.
Now, it will take some time, sir. Just wait for a few seconds.
Is it fine?
Yes, it is okay, sir. You can go ahead, sir.
So mostly I will be talking about 5G and the challenges and enabling technologies, and definitely one of the enabling technologies is small cell, right? So my talk will be introduction, then a brief idea about 2G, 3G, 4G, how it was involved, and requirements for 5G, and what are the challenges and facilitators. Finally, R&D technology areas. There are very 5, 6 important technology areas, and one of that is small cell or HETNets. And finally, conclusion and references. Right? I don't know whether this slide is visible or not. I'm at slide number 3. Better I
Sir,
will
there
go
is a
to
slide. Yes. Your slide number 3.
better I will not go to slide mode, full slide screen. I will increase it. Is it fine now? Okay.
Yes,
Yes,
okay. Good.
So this is about the evolution of wireless cellular communication, and you can observe that. You can observe that on the x-axis we have data rate, and on the y-axis we have mobility and coverage. The important point what I'm trying to make out here is that the red linear curve, that is a spectral efficiency. So a spectral efficiency, that what is the amount of information you are sending per unit bandwidth, and that is very critical when we are moving from 1G to 5G and 6G, right? So when we are moving from 1G to 4G and 5G, the spectral efficiency has a linear curve. So this is a very important point. One point. Second point is about the spectrum, licensed spectrum and unlicensed spectrum. So these cellular networks, mostly they are using licensed spectrum, and some of the very popular technologies like Wi-Fi and Bluetooth, they are using unlicensed spectrum, right? So what we have witnessed is that when we are moving from 1G to 4G and 5G now, so there is improvement in different aspects like mobility, coverage, data rate, and quality of service. And the important point is that from 3.5G to 5G, they are packet switch. So packet switch has become very important. So all the traffics are routed through IP protocol, and most of the important services are licensed. They are using licensed spectrum, right? Now, coming briefly to the 2G standard, because even though we are in the 5G and beyond era, but still 2G has an important role to play. And if you can observe that 2G has two standards, one is 2G and 2.5G, and 2G stands mostly by GSM. And ironically, you can observe that GSM only supports 10 kilobits per second, but 2.5G, that is GPRS and Edge, they can support up to 50 kilobits per second and 200 kilobits per second. And mostly this 2.5, 2G was mostly for speech communication at a data rate of 10 kilobits per second, but 2.5G was for low data rate internet services, wireless internet services. So, and because it was very popular in the 1990s, but at the end of 1990s, what we felt that yes, there is a need of more higher data rate wireless technology which can support higher data rate for internet browsing and data services, right? And that led to the development of 3G. So interestingly, 3G also had two generations, 3G and 3.5G. And 3G has two prominent technologies. One is the WCDMA, that is wideband CDMA, and the other name is UMTS, right? Properly known as UMTS. WCDMA is properly known as UMTS, and then CDMA 2000. And these two standards support 384 kilobits per second, which is quite significant. And again, 3.5G, which is very, very important. 3.5G has two standards, right? And interestingly, both can support 5 to 30 megabits per second, right? 5 to 30 megabits per second on a wireless channel. So the advantage is that when we are moving from 5 to 30 megabits per second, because for any multimedia or video conferencing or video call or anything, the minimum data rate requirement is 10 megabits per second, right? The minimum requirement for any video conferencing, video calling, or multimedia services, the minimum requirement is 10 megabits per second because the amount of information is too huge. So this 3.5G was able to enable us the services of video calling, video conferencing, and all. And that was a turning point. That was a turning point in 3G standard, right? So from 2005 onwards, we were able to, or I can say, we were able to do this video calling and video conferencing using the mobile handset, and thanks to the two important technologies, that is HSDPA and EVDO, right? Now coming to this 4G, which is presently 4G is everywhere worldwide, and 4G has three standards: LTE, WiMAX, and LTE Advanced. And mostly we use LTE for 4G. They are used interchangeably, and the interesting point is that this 4G can support a data rate of 100 to 200 megabits per second, right? That is quite significant increase compared to 3G or 3.5G. So we are getting almost 5 times more data rate, right? 5 times more data rate in the 4G. And this 100 to 200 megabits per second. Then WiMAX was also a popular standard, but although it was not, LTE was very popular, and somehow WiMAX lost its relevance nowadays. But still, it is a good technology, and it provides 100 megabits per second. And The point here, what I am trying to make you that why uh, from 384 kilobits per second we have moved to 100 megabits per second. What was the reason? What are the two important technologies which made it possible? Then the two important technologies which made it possible is that these are called revolutionary technologies. The 4G is based on the revolutionary new technologies based on orthogonal frequency division multiplexing and multiple input, multiple output antenna system. So OFDM, that is the orthogonal frequency division multiplexing, and multiple input, multiple output MIMO systems where the technology which made it possible to transmit over air a data rate of 100 megabits per second. This is very interesting to understand, right? And as far as service is concerned, application is concerned, right, in the 3G, 3 to 3.5G, where data rate was from 300 kilobits per second, 30 megabits per second, we are able to do voice, data, video calling, and video conferencing. But when it came to 4G, which supported 100 to 200 megabits per second, there are two additional services which can be provided over 3G was online gaming and high definition TV. The high definition TV important point is that for each stream we need minimum 10 megabits per second, and HGTP requires multiple streams. So it is possible only when we are going from 4G. It was not possible in 3.5G, right? So this is journey from 2G to 4G. Briefly, I have mentioned you. Now coming to this fifth generation, what are the challenges? If you see this slide, very interesting slide that we have capacity, latency, energy consumption, cost, user data rate, and coverage, and then there is dotted line, which shows the physical limit. So we are very close to the physical limit of all these important parameters, right? So about the traffic in 5G, what will the traffic? So this will be 10,000 times more compared to 4G, right? Traffic is going to increase 10,000 times, 10,000 times more. Devices will be 100 times more. Latency we are talking about, talking about latency of in milliseconds, few milliseconds. Battery life for machine to machine type communication, we are targeting 10 years. For cost, this machine to machine communication, the cost would be ultra low cost, right? And the peak data rate that is for fixed point to point communication, we are targeting 10 gigabits per second. And for low end data rates with mobility, we are targeting 100 megabits per second. And reliability is, we talk about very high reliability, right? So in quick, so 1 to 10 gigabits per second data rate in real network, 1 millisecond round trip latency. This is very critical, 1 millisecond. This is target of 5G, that round trip latency should be 1 millisecond. And almost 100% coverage for anytime, anywhere connectivity. And the last 2 points are very important. We are talking about reduction in energy consumption by 90%. Although we are talking about very high data rate, lot of devices to be added, traffic 10,000 times more, but the energy reduction should be almost 90%. This is very challenging. And here the role of small cell is very important. And then talking about low power consumption, right? So these are challenges, right? And just one challenge I will talk about, the latency, round trip latency, and where the small cell has a very important role to play. This latency term, right? So if you see that in LTE, that is 4G, the latency is around 10 millisecond, right? And if you can see that, why this 10 millisecond latency we are targeting in LTE, because this mobile device itself take 4 millisecond, right, to do all this processing. And this in the network part where we have BTS, then core network internet, they will take typically around 6 millisecond, right? So in total, the minimum what we can get is 10 millisecond in LTE. From this 10 millisecond, we want to go to 1 millisecond in 5G, right? This is target. Although we have not achieved this target, we have around 4 to 5 millisecond right now, which is practically possible. And to do that, we should have a latency of less than 0.5 millisecond. In the mobile processing, everything we need to do in 0.5 millisecond. And for this this network part, everything should be done in 0.5 millisecond. And that's why we are talking about the content delivery, right? The whole content will be delivered. Then only we can ensure the latency of less than 0.5 millisecond, right? This is just one challenge I have told you, that from 10 millisecond, how it is difficult to come to 1 millisecond in 5G, right? So this is typical when we talk about wireless outlook 2020, right? Beyond 2020, and we are in 2022. And so basically, this 5G has, or in general, we talk when you think about wireless technologies in beyond 2020, right? In this decade, so basically, we are talking about basic type of services, right? Broadly classified as enhanced mobile broadband. So whatever mobile services we are having in 4G, this will be enhanced. So we are talking about enhanced mobile broadband in this decade from 2020 to 2030. And here, what are the requirements? Is very high data rate, high spectral efficiency, high mobility, low PAPR, simplified receiver design, and high density. These are requirements for enhanced mobile broadband, right? And then most of the things which is we are moving is that we are talking about massive machine type communication. So predominantly the communication in this era, this decade, will be machine type communication, and these are the requirements. And one of the requirements, that is IoT, we are talking about. IoT is everywhere, and in this IoT we have non-orthogonality, high spectral efficiency. These are the requirements, and minimum outer band radiation. So some of the applications for internet IoT is sensor networks, so smart grid, smart cities and homes, intelligent transport systems, etc. So this comes under IoT. Then very interesting application which has come up in 5G, which was not there in 4G, is ultra reliable low latency communication, right? Ultra reliable low latency communication means that we are talking about sub millisecond latency, immune to Doppler. So even if the mobile is moving or the vehicle is moving, it should be immune to the Doppler and low complexity. And few of the applications are tactile radio, autonomous self-driving vehicle. So if you just imagine that if you are talking about self-driving vehicle, autonomous self-driving vehicle, so it has the human sensing capability. It should have the intelligence of human brain, right? So everything should be done in some millisecond latency, right? And it should be immune to Doppler and all, right? So this has posed a different type of challenge in 5G, right? So moving ahead, so now how we are moving from 4G to 5G, how we are trying to get this. So basically, there are two tracks, two paths to reach this 5G. One part is that let us evolve this LTE Advanced, which is 4G or 4G technology. Evolve that technology, add more advancement in those 4G technologies, and try to get services of 5G, right? And here I would like to remind you that these services, which is by evolving this 4G, is around 6 gigahertz bandwidth only, sub 6 gigahertz bandwidth, right? This evolvement is in that band only. And then we are talking about paradigm shift, so new radio technologies, right? That is millimeter wave and massive MIMO. These are all the new radio access technology that is millimeter wave, right? So these are two paths through which we are trying to get these services, right? Now, what are the R&D areas, right? R&D areas is like if you see this slide, uh, there are so many technology in LTE advanced, and we know that some part of 5G will be met by evolving or advancing LTE advanced. So these are some of the technologies which are common between LTE advanced and 5G. But in 5G, we have some specific new techniques, which is new technologies, and which is very important, like new multiple schemes, new coding schemes, high frequency band, that is millimeter wave and all. That's important for 5G. Now, just one application I'm just trying to highlight, that is facilitators addressing to the challenges, right? So one challenge is what capacity and data rate. So if you want to increase the capacity and data rate of these 5G services, what are the enabling technologies, right? Because capacity is going to increase 10,000 times, right? Data rate, we are going to 1 gigabits per second. So what are what are the technologies, or what are the facilitators which is going to help us? So one is definitely a spectrum. So we have to use high spectrum and other spectrum options like pooling and aggregation. So pooling and aggregation is also important to improve the spectrum efficiency. Then we are talking about massive MIMO and new air interface. That's very important, because new air interface and multiple access techniques can be designed to provide optimized high frequencies, latencies, and massive connectivity. Now coming to these small cells. Small cells, why this is important? Because this small cell bring communicating endpoints close together. So these communicating endpoints are closer together so that we can have more users to be added in the system, and the data rate can be increased, right? So a small cell has a very important role to improve the capacity and data rate, right? So there are other challenges like end-to-end latency. Here, end-to-end latency also we are talking about all optical network, new air interface, local offload. Local offload means that we are talking about a small cell. So bring communicating endpoints closer together. So when we are communicating endpoints are closer together, then definitely your end-to-end is very important. Then coming to the massive number of connections, definitely for massive number of connections, we have to make small cells. More numbers of users are being added. Otherwise, there will be a lot of interference if we have one bigger cell, right? So local offload, that is bring communicating endpoints closer together. So this basically local offload is possible only when we are talking about small cells. So this small cells is going to help us to add the number of users also, massive number of user connections, apart from other techniques, right? So these are the important 5G technologies. That is the new waveform design, massive MIMO, then headnets or in small cells, device to device communication, and millimeter wave and connective radio, right? So just now we'll have some few broadly I want to discuss about the headnets or small cells and headnets. They are used very interchangeably, and you can observe that. So we have it consists, what this small cell consists of, a mix of high power macro cells and low power nodes. Low power nodes means what? Pico cells, femto cells, macro cells. So this small cells is basically made up of pico, femto, and micro. So you can see that we have a base station at the center of the cell. Then we are talking about this radio resource head, then pico net, pico cells, then femto net, right? Then we are talking about the relays. So these all are part of the small cell. So bring serving base station closer to the user. So what we are doing in a small cell, we are bringing the base station closer to the user. What is the advantage? Efficiently supporting high traffic rate and quality of service. When this base station is coming closer to the user in the small cell, what will happen that it can support higher traffic rate as well as quality of service will be improved. Second important point is that improves indoor and cell edge coverage. So when this base station is coming to the small cell, or in case of small cell, it improves indoor coverage, right? As well as cell edge coverage, because cell edge is always a tricky issue when signal strength is less. So if you are making a small cell, the cell edge users can be covered very easily. Offer opportunity to lower transmission power, saving energy at base station. So if you have a small cell, you can transmit at lower transmit power, right? Because if you have bigger cells, the base station has to transmit at very high power. So if you have a small cell, so you will be able to transmit at lower power, saving energy if energy at the base station. This is very important because we have to reduce the energy consumption by 90%. So the small cell is very important for that also, right? But there are challenges for this small cell, because if you have a homogeneous network, then we are talking about a single macro cell, and it can serve different base stations, right? So advantage is that a single cell, big cell, but homogeneous network means that we are talking about big cell. So large cell size, hexagonal coverage, poor quality of service at cell edges and indoor environment. So when we are talking about large cell, right? So in that case, what will happen that there will poor quality of service at cell edges and indoor environment. When we are talking about small cells, that is heterogeneous network, where we have a macro cell, that is base station, we have small cell base station, right? So we have different small cell base stations. We have small cells, this blue colored, they are the small cell base station. And what you can observe that what are the key features, and the network becomes heterogeneous. Invariably, this small cell network is a heterogeneous cell, right? Heterogeneous network basically, compared to homogeneous network. What is a key cell? Small cell size. A small cell include micro, pico, and femto, and increased capacity and consistent quality of experience everywhere. This is a very important point. With a small cell, the capacity can be increased and consistent quality of experience everywhere. And what is required is that strict interface management schemes required. When we are talking about small cells, because there will be multiple small cells, so strict interference management is very much important in small cells, right? So what are the challenges in small cells? So head nets or small cell, head nets and small cells are used interchangeably. Head nets require the changes in following important aspects. Network topology will change when you're talking about small cell association. The backhaul deployment will change if you're talking about small cell, and the interference management. Mobility and interference management are the most challenging issue in head nets or small cells. What is important is that if we are talking about small cells, we have to talk about the mobility management, because a small cell that there will be frequent change over the base station, right? Whenever the vehicle is moving or user is moving, there will be frequent handover, right? In the small cell, and interference will be very high because there are multiple users, there are multiple cells. So interference management is also very important in small cells or head nets, right? Thank you.
Thank you, Dr. Pritamji, for delivering a beautiful topic, and we have nicely covered the world of 5G. So thank you once again.
Thank you,
Please
sir. Thank
please be with us. We may face some questions from our audience, from our participants. So in question and answer sessions, your kind assistance is required. Thank you once again.
Okay,
So
I will
now,
try to be. I will try to be there. I have a meeting, so if before that, if I'm free, I will be here. Right?
okay, sir. Okay, sir. Thank
Thank
you.
you.
Thank you.
Thank you.
Shall I close the presentation? Your
Yeah,
presentation?
yeah. I'm closing.
Thank you. So now we are coming to our fourth and final session, final speaker sessions, basically. In our fourth session, the session topic is on accessing street furniture for small cell deployment, issues, challenges, and implementation plans. Sri Ashish Mittal of American Tower Company will grace this session as the distinguished speaker. Mr. Ashish has over 20 years of experience in telecom space, has joined ATC in 2018 as General Manager, Optical Networks. He is responsible for fiber, small cell, and platform extension. Prior to ATC, he was working with MTS India as head network planning. So over the station to Sri Ashish Mittal.
Good afternoon, everyone. So I heard many speakers in the past 1 hour. So I will not talk about technology per se, but I will talk about infrastructure per se. So we have been talking about the throughputs, the speeds, etc. So I will take a little shift on that, and we will be talking about the infrastructure layer, and that is the physical layer on which all of these will be working. I would be happy to answer the questions. Please stop me wherever you feel like. So this is how the cellular network have evolved. Nila, is my screen visible?
Yes, yes, yes. Please continue.
So from 1G to 2G, and now we are talking about 5G. So from 3G onwards, it's more of a data-centric networks. So till 2G, it was more of a voice-centric network with low speed data also there. So data speeds were in kbpss. From there, 3G actually brought data traffic into play with 21 Mbps plus throughputs available. With 4G, we have 100 Mbps plus throughput available. And with the carrier aggregation, we can even go up to 300 Mbps. 5G targets about sub 1 milliseconds of latency and 1 Gbps plus of throughput. The key here is that 5G is not only talking about data services, but it is also talking about real-time application and massive machine-to-machine communications, which needs a very low latency, high throughput networks. May not be high throughput network in the case of IoT, but low latency definitely is required. So, corresponding to the technology, I have tried to plot how our infrastructure requirement shifted. So, if you recall 2G bulky BTSs on a 60-meter towers, or even if we had a rooftop tower, it was 22-meter plus, largely on a microwave network, high power consumption using 10 kilowatt of plus power. These high, not ruggedized, needing uh, more of air conditioning. And when we talked about in-building solutions, it was largely RF repeater. In 3G, a shift happened. So it is like that. With every technology coming in, then the networks are becoming dense, and the heights of the height required is getting reduced. So with 3G insertion, we shifted to rooftop poles and OFC started coming in. The throughput is increasing. A high throughput network, which is optical fiber network, starts coming. Boxes become more rugged and air conditioning goes off from the sides. And the BTSs also, the power consumption reduced largely due to the advent of technology, and also a distributed architecture came which requires much lesser space. Now coming to 4G, what transpired from 3G to 4G? With 4G coming into picture, small cells came into picture. For small cells, street furnitures came into picture, and the deployment becomes all outdoor sites. So typically now, almost 95% of the sites, new sites being placed by any operator, is typically outdoor sites. We had an OFC network in the 3G also, but in case of 4G networks, we will be talking about 60 to 80% fiberized site, whereas we as a country currently are sitting at 30% less, in and around 30% of fiberized sites. When we go to 5G, street furnitures will dominate the market. That's what we understand. Small cells will small cells will dominate the networks. 95% to 100% is target fiberization. So what all this will mean? All this means a very, very dense network, dense in all aspects of business. When we talk about micro networks, it will be small cells and Wi-Fi game, as my previous speaker said, a sort of HetNet network, Wi-Fi and small cells. A very dense indoor systems will become more dominant because uh, 5G predominantly will be 4G itself, and 5G coming will be on the mid band. So indoor coverage will be challenges. So more play for distributed antenna systems inside the buildings. Fiber will be the key. Why small cell is becoming so and so dominant? High system capacities and high user data rates are driving the future networks. And small cells offering flexibility in terms of low cost points, all outdoor designs, very rugged boxes, a very small form factor boxes. In my next slides, I will show you some pictures of the small cell deployed by us. Ideally, to be deployed on a street furniture. Street furniture, when I say, it's street lamps, utility poles, bus stops, hoarding boards. All are these target street furnitures. It only not only takes care of capacity, but it also takes care of dark zones and macro cellage traffic. We understand, we as an American Tower understand that the future will be small cell or dense networks. So we try to do a case study by deploying a smart cluster in one of the most crowded market of Delhi, typically of 1 square kilometer of area. Here we collaborated with Tata Power, one of the leading power distribution companies, and used in excess of 600 poles of there to deploy these smart clusters. So what we did is that typically 4 to 6 meters of height was available to us in this at these poles based on their current electrical infrastructure. We laid 15 kilometers of fibers covering all major streets of that area. The idea was that our fiber network should be like that in a day's time, we should be able to cater to operator requirement. So if an operator says, "Ki, we want a small cell here," so the existing fiber network of our should be available in less than 5 poles distance. So typically 100 meters. This fiber network was made very resilient. Multipath redundancies were done so that there is no outage because it was an aerial fiber network prone to cuts. So we mitigated that risk by multipath redundancies. So then we designed the boxes to have network switches at all the small cell locations for carriage of traffic, and these traffic was taken over on our network to two of ATC sites, which were acting as a traffic handover point, and we're having NNI with all the leading MNOs. If you see right side of the picture, the red dots on the map are all small cell deployments, and the two pins in red color are handover points, and all the green cables are the poles through which our fiber is passing. So typically, a 400 plus kilometer, 400 plus poles having 15 kilometers of fiber. This was on the fiber piece and alignment with Tata Power, but the normal pole needed to be retrofitted to take care of small cell deployment, and we would need power connections. So Tata Power agreed to provide us 2 kilowatt of power connection at the pole itself, solving 50% of our problem. So meter power was available at all the small cell locations, and we did groundings, etc., just near to the poles. Each small cell, due to the limitation of loading on the pole, each uh, each pole was allowed to put two small cells. So the basic idea was that overall additional loading that we could put on the poles was something around 70-75 kilograms. We to keep the load confined to that range, we reduced the power backup, but 60% side were still with an battery backup, and the battery backup was confined to 1.5 hours. Largely in these markets, there is hardly any power cut, and specialized box was designed to take care of fiber termination, network switch, and AC and DC backups. That's was our pilot case in the smart cluster. I will take you through some pictures. So these are pictures. In the first picture, you can see the maintenance-free gel earthing was put across by us just near to tower to support retrofitting of the towers. In this picture, you can see the aluminum pole and the box in which network switch, fiber gets terminated, AC and DC system along with battery backups. We use lithium ion battery to reduce the space and weight over there. So the poles were put in such a way that they allow 180-degree orientation to small for deployment of small cells. All these were taken consideration. The key consideration was spacing from the electrical cables. So we maintained a 1.5 meter isolation from the existing electrical infrastructure. If you can see this orange sheets, these are PVC conduit sheets which were used to isolate our deployments from the pole to avoid any chance of electroculation in terms of rainy days, etc. So there were multiple things what we did. So any small cell deployment typically is of no use if it is not backed by fiber, and fiber will be the key for small cell deployment. I am not saying that small cell will not work on micro network, but to give the right user experience, fiber is key. So this is what we did. We deployed fiber connecting all poles. This was structured cabling. It was not a hanky-panky cabling, what a local cable operator, etc. doing. Proper cabling with structured things, no slackness, distance being maintained, and all such things. So we had some approach and learning, and from this project, the key point was separation between conductors and telecom infra. And after a lot of deliberations, we and Tata Power agreed that 1 to 1.5 meter separation is key to avoid any issues to us as well as hindrance to their operation and maintenance. Safety was Safety consideration came into picture. So specialized kits, specialized uh, staircases, stairs for climbing the poles, etc., were required, and there were certain SOPs agreed for deployment operation to take care of safety, not for only for us while deployment and operation, but the O&M team of Tata Power, so that our boxes don't hinder to their operation and maintenance. Max loading was again a challenge because these four were typically designed to take care of electrical infrastructure. So a lot of deliberations were done, and finally we agreed that if we keep ourselves confined to 6, 7, 8 meters height, 70-75 kilo of loads can be additionally put across. And we tried to keep everything within that window. So these were four key aspects which were hindering small cell deployment with Tata Power. We did multiple prototypes with them prior to creating this infrastructure. So we customized the designs to reduce load. So all sheet metal was thrown off and aluminum was used to reduce the weight. So we were typically able to reduce 10 to 12 kgs of weight by putting all aluminum thing. Structured cabling was done with a specialized fixture. So the key concern from there was the cable should not have slackness. It should not hinder. It's with them in case of windy. It should not get encircled to their things. So we used specialized fixture. The third most challenge was that how do they know that we are licensed providers and have we put the cable with due permission of Tata Power. So we tagged all our cables on the both side of poles with a 6-inch by 3-inch strips with ATC fiber cable known, so that their operation teams clearly knows that we are not unauthorized ones and they don't disturb our installations. The key supports from Tata Power came in form of the most critical one was grid power connection availability at poles, which sorted out 50% of the issues. A very clear guideline was given to their field team by their corporate that nothing has to be declared not feasible, and any poles which they say is not feasible has to be jointly inspected and agreed upon by both the parties. A strong governance mechanism was also laid down at field and corporate level for faster resolution. Basically, they devised a standard operating process and it circulated down to their team that these are the standard terms, and if we are adhering to that, we may be allowed. So these were key things which made the POC successful. Although my topic was on small cell, but what I feel is that beyond small cell, street furniture is more importantly required for aerial fiber deployments. Without aerial fiber, uh, street furnitures and authorized ROW, aerial fiber deployments is practically not possible. And why we say aerial fiber deployments are key in futuristic networks is that small cell with fiber is the demands from the operators. And we forecast that small cell deployment in the country will grow at a rate of 20% CAGR in next 5 years. As I spoke, the densification is not only on the radio layer, but densification is also happening on the uh, fiber layer. So we need to grow from 30% site fiberized to 70-80%, and all of these will not essentially happen on underground cabling. And we we have a time frame of 3 to 4 years to do that. So aerial fiber will be key to handle that. We expect that at least 20 to 30% sites would come on aerial fiber if proper ROWs etc. are being given by the power discom companies and local cable and this local authorities. Third and foremost thing, which was is fiber to the home. ADSL 2 plus is getting out so obsolete, and FTTH is new thing for home broadband. This pandemic has teased us that a strong broadband, a very robust broadband connection in our home is like any utility services. So earlier we used to say there are three utilities, that is power, water, and PNGs. Now there is a fourth utility coming into picture, which is a home broadband. So we understand that this will be very important uh, for both power discoms and local authorities to make open their utility poles for such deployments. That's all from my side. We'll be happy to take questions if any.
Uh, Datta,
Yes, sir.
just before we move on to panel discussions,
Yes, sir.
just I want to put forward few issues because uh, Ashish ji and Kholi ji both are there. Sanjeev ji.
Yes, sir. Yeah.
So few days ago we met Commissioner Kolkata Municipal Corporation. And because of our platform issues, the DG Electrical or DG Lighting, Kolkata Municipal Corporation, he has joined or he is already watching through our YouTube channel. So what Kolkata Municipal Corporation is interested that they need a kind of proof of concept, even if it is only 3, 4, 5 dipoles. So since there is ATC, Indus, Ericsson, Nokia, and 4 TSPs,
Right.
so we will just have a discussion with all of you, means 4 TSP, 2 OEM, and 2 or 3 or 4 infrastructure providers. And then we have to find out some environment, maybe in the academic environment like IIT campus, maybe in the hospital environment, maybe in the agricultural environment, means basically the use case scenario we have to find out. And maybe at a very, very smaller scale, maybe we at a very, very smaller scale, we have to start some kind of use of street furnitures. So maybe it could be a, like Dr. Bhatta has said, that on the bus, because a lot of comments are coming that said do something for the rural areas. So that means we can do in 4 or 5 different scenarios. One could be the education. Education will be the real killer application for 5G, electronic health, and then maybe in the rural environment. So we will have a discussion on it because the Kolkata Municipal Corporation has specifically asked that we do not want to see the case studies of abroad, but we want to see it on our own eyes, and then we can put forward to our higher authorities that what should be the way forward.
Absolutely.
So,
I fully agree.
I wanted to take this
yeah.
platform because everyone is here. And Ashish ji has very, very categorically said that 5G or using small cell on radio, he's talking about 1 square kilometer area and they are using 400 such poles. Am I correct?
Yeah, you are correct.
So,
typically
100,
distance
so
between two poles-
Calcutta Municipal, same thing I told to Calcutta Municipal Corporation. The Calcutta Municipal Corporation is 200 square kilometer area, densely populated. Now, if I take this is as a simple thumb rule, so 200 multiplied by 400 is coming around 80,000. Am I correct?
You're right, sir, that average distance between two poles is average out 30 meters in our country, but the calculation will not be directly multiplied because
anyway, I am just talking about that it will be not less than some 50,000 light poles.
so
And
typically
they are-
20 to 50,000 poles will be
Exactly.
required
So,
by industry in
there
near
is a need for a business model. There is a need for a business model. When I just emphasized, Commissioner sir, that sir, cable laying along the road, along the light post is to be done by Kolkata Municipal Corporation through some company. They said, look, this is not our core business. We are not going to look into it. So if we can find out some kind of business model, maybe with the transport department, maybe with the corporations, so maybe and in different environment like the educational environment, hospital environment, agricultural environment, then only 5G use cases for the Indian context and especially for the eastern zone, because eastern zone the penetration of smartphone, computer literacy, communication literacy, and the appetite is not that high. So appetite in every sense. So the whatever will be deploying is Ahmedabad or Bhopal, or so far as Bangalore Metro, that may not be exactly or cannot be or should not be exactly replicated in eastern zone. There are issues. There are issues in Bihar, there are issues in West Bengal, there are issues in Jharkhand, so we have to understand that. So with this, I just want to thank you all, and we'll be going for a panel discussions. We'll be requesting all of you to be there. There are certain some questions, but those are very, very general in nature. So I think we can move to the panel discussions, and then we can see
Sir,
if we can take any questions.
so it's a small request. Actually, there are certain limitations in this AirMeet platform. We cannot accommodate more than 10 speakers in a particular session. So in the panel discussion and question and answer sessions, we have already 10 speakers, except our distinguished speakers in the speaker sessions. So
then,
it would be better
then
if
Doctor,
you...
it is better you give an opportunity to the participants to raise
Yes,
the
sir.
hand.
Yes, sir.
They can
Yes, sir.
raise the hand and then they can be brought into the virtual dais, and
Yes.
then there could be questions and answers.
So
In
if
the
we...
meantime, I am looking into the chat box.
Okay, sir. Okay, sir. If we conduct that question and answer session now, that it will be better.
Yes,
So it's a
we
request
conduct.
to participants, those who are watching through laptop or desktop, they have the opportunity to join in this virtual dais. You will get a raise hand option there. So please click that. Then I can able to make you join in this virtual dais. You can raise your queries. One Mr. Utpal Raj is there. I'm going to make him join. Mr. Raj, good afternoon. Please unmute yourself. Mr. Raj, please unmute yourself. Yeah, please. Mr. Raj, you please raise your query. We are not able to hear you. Sorry, please rejoin us. So it's a request to other participants. You please press that raise hand option, or otherwise you may post your queries or suggestions or whatever your.
There is one Mr. Vikas Diwan. He has posted so many questions, rather his observations, that 5G is going to create a negative impact. And he has cited a lot of research papers also. So if he is there, he can be requested to join.
Mr. Diwan, if possible, you please join with us.
No, he can raise the hand and then join.
If you are watching through your laptop or desktop, you can join with us by pressing that raise hand button. Mr. Diwan, please unmute yourself. Haji.
Yes, namaskar to all.
Namaskar, please.
My name is Vikas. Yeah. My name is Vikas Diwan, and I am from Awaken India Movement and also from Free Earth Alliance. We are working on various subjects related to health and also on this matter, which is currently being discussed. I have raised several questions from peer reviewed studies and the appeals and statements of the experts, including professors of ITs and also the medical experts. We are on the verge of commercially rolling out 5G in India. How can we assure citizens of India and all the living organisms, including animals, bees, and the flora and fauna, that this technology will only help us and not harm us? Means it is the risk is not outweighing benefit.
Mr. Vikas, we understand your concern, rather not your concern. There are majority of the population, especially in the developing countries and developed countries also, they are raising these questions. But you have to understand one simple thing. Free में launch नहीं मिलता है. That means if you want to get any benefit, there is a harmful effect. But whatever you were citing the research paper and all this, I could not find time to go through it. But we are telling you one simple thing. The actual technical answer will be possibly can be given you by our Dr. Datta from IIT or Dr. Pritam Kumar from IIT Patna. But I just want to assure you that in India, the radiation level from the big towers is 1/10 of the international standards. So knowingly that there could be, even though nobody has proved either through an empirical study or through any technical study that yes, radiation is having a direct impact on bird or radiation is direct impact on COVID. But yes, there are claims. I am not telling those who are claiming they are claiming false. They might be thinking or they might be assuming or they might be having certain data. But as on date, this is not proved. Second part is that India from the very beginning has taken a very, very cautious approach about the power of towers for radiation. And so far as international standard, we are radiating at 1/10 of their level. So that is definitely a good I should say, steps taken by Indian government. But whatever questions you have raised, yes, there are certain issues, there are certain concerns. We are not telling that it is totally false, but we can tell you with certainty that it has not been proved very rigorously, through very rigorous studies. So I will now request Dr. Datta or Dr. Pritam Kumar from IIT Patna.
Sir, unfortunately, they are not available.
Huh?
Unfortunately, they are not available now.
They are not available. Okay, no problem. So if they are not available, at least I can tell you with this that in India, especially again, I will reiterate, whenever we do any consumer outreach program or DOT is doing any program, they give you clear explanation, clear statistics, data that what India is following. And not only that, our Department of Telecom field units, we have a field unit in every state, however small it is. Even in Andaman, for a population of 5 lakhs, even in for Sikkim, for a population of 5 lakhs, we have a DOT officers at a very, very higher level. And they are going to the field doing some sample check. It's not only the operator is claiming. So that means there are concerns, we are not doubting it. But in India, we can assure you that the level of संजीव जी आप बताइए मतलब जो लेवल का बात है
बिल्कुल सर आई fully agree with you. In fact, if you allow, I would just like to share my screen for a few seconds. So just to elaborate on what Dr. Samantha was saying, so this is the draft the document proposed by TRAI, right, for the street cell furniture, and these are the EMF radiation norms for mobile towers in India, right? So if you see the global radiation norms for the various bands 900, 1800, and 2100, that is, for example, for 900 megahertz, it's 4.5 watt per square meter, whereas for India from 2012 onwards, they are 1/10, as Dr. Samantha was saying. So if the world is following 4.5, India is at 0.45. Similarly, as compared to 9, we are at 0.9, and instead of 10.5, we are 1.05. And the same will be applicable for till the 10 gigahertz, which is the 5G band. So effectively, I mean, this is one of the precautionary or the prudent step that has been taken by the government already several years ago. So, but at the same time, this means that the number of small cells will have to be increased in order to provide a good coverage. So it's a trade-off, you see, at the end of the day. So, but having said that, the EMF radiation norms in India, they are 10 times more stringent as compared to the global norms. And that should certainly help to minimize any negative impacts of radiation. But yes, there are pros and cons for both. And as Dr. Saman said, the detailed studies would need to be perhaps carried out. Yeah. Thank you so much.
I beg your pardon, sir, and to the esteemed panel. that we are presently in this session discussing about the future, about the coming days, and the low latency, high speed networks. And we are presenting the data of 2012, stating that we are actually using 1/10 of or being applying 1/10 of a frequency level. This is actually we are actually making people fool by stating these kind of things.
Because I requested you, we will be talking one to one. This is not the time. Whatever Mr. Kohli said and whatever I am telling, it is a standard of 2012. That does not mean it is not following today. It is being followed even today. For your kind information, it is being still followed as on date.
Since 2012, this is the
But
norm.
sir,
Yes.
if we talk about the millimeter wavelength of 30 gigahertz and more by creating the mini cells, how can we say that the radiation level will be lower than the international standards?
Because see, we talk one to one. This is not the forum for all the discussions. I appreciate your concerns. We'll be talking one to one, okay? But we cannot go on arguing one by one, okay? Please excuse us. Datta, if there is
Thank you,
anybody
sir.
else.
Thank you, sir. Thank you, Mr. Vikash, for joining with us. Is anybody
Thank you.
there
Thank-
to raise your hand? Or otherwise, we'll close these sessions and go for the next one. Mr. Utpal Raj is there. Sorry, I am finding some problem with Mr. Raj. He is not able to join.
Hello, sir.
Mr. Raj, you please try once again. Or otherwise, we'll go for the next session.
I think he can join in the next session.
Okay, that would be better.
So I think you can go for panel
Okay, sir.
discussion.
Okay, sir. Actually, we are already delayed by 10 minutes. So it's time for our next sessions. That is the final one. That is the panel discussions on use of 5G, use of street furniture, and the role of different stakeholders. And after that, you may raise your queries also. So those who are watching through WearMeet platform, please be with us. And those who are watching through YouTube channel, you may be disconnected for a while, but please reconnect yourself when the panel discussion starts in a few seconds. Thank you all once again. So we are going towards our next session.